You can't talk about climate without talking about geology. Rocks, soil, and water move around Earth in a bunch of different ways that change the planet and its climate. And humans have changed those processes, and they've changed us right back. So let's go to the layers and learn about Earth's dynamic systems. Welcome to Crash Course Geography, the study of Earth's dynamic systems and how humans interact with them. We're going to explore all the ways that rocks and weather and people affect each other. Let's start by thinking about Earth's structure. Now there are lots of ways to slice up the planet, but for now we're going to focus on two slices. First is a vertical slice through the crust and part of the mantle called the lithosphere. The lithosphere is made up of tectonic plates that move and interact with one another. For example, the Pacific Plate and the North American Plate collide along the west coast of the United States. The denser oceanic crust of the Pacific Plate subducts or slides under the less dense continental crust of the North American Plate. The subducting plate melts and the rock deforms into new igneous and metamorphic rock. This creates mountain ranges like the Cascades and the Rockies. And as the plates pull apart from one another, magma rises to fill the gap and forms new crust. So the lithosphere is constantly being recycled and renewed. The process of plate tectonics not only makes mountains, it also makes ocean basins and the features along the edges of these plates, such as deep ocean trenches and mid-ocean ridges, which are underwater mountain chains. These landforms affect the patterns of wind and ocean currents that influence climate. Plate tectonics also affects climate through volcanic activity. Volcanoes form when molten rock or magma from inside Earth escapes through a crack in the crust. Volcanic eruptions release gases like water vapor, carbon dioxide, and others into the atmosphere, which can trap heat and warm the planet. But volcanoes can also have a cooling effect on the climate because during an eruption they eject ash and sulfate aerosols into the stratosphere. Ash can block sunlight and lead to a temporary cooling of the planet. Depending on the size of the eruption and how much material is released, volcanic eruptions can affect global temperatures for years. The second slice we need to consider is a horizontal slice through the near surface of the Earth, including the uppermost part of the lithosphere, the crust, and the lower parts of the atmosphere and the hydrosphere. Just like the lithosphere, the atmosphere and hydrosphere are always changing. Together, the lithosphere, atmosphere, and hydrosphere drive the rock and weather cycle. The rock and weather cycle shows how the three spheres work together to shape the Earth's surface. It begins with rocks. As rocks weather, they break down into smaller pieces and are transported by water, wind, or ice. Over time, these sediments are deposited in new locations where they may become part of a new rock formation. Weathering is the process that breaks rocks down physically or chemically. Physical weathering happens when rocks are exposed to the forces of nature like rain, snow, ice, or wind. A walnut-sized raindrop falling at 9 miles per hour has enough force to erode soil and rock particles. As water freezes and thaws, it expands and contracts, pushing rocks apart and breaking them into smaller pieces. Chemical weathering, on the other hand, alters the composition of rocks through chemical reactions. When rainwater mixes with carbon dioxide in the air, it becomes slightly acidic and starts to dissolve some rocks while leaving others like granite and basalt relatively unscathed. Water's ability to cause weathering depends on its chemistry, which is affected by the gases in the atmosphere. For example, when ocean water evaporates, it leaves behind salts that make seawater more dense and sink to the bottom. When cold, deep water rises to the surface, it brings nutrients and minerals to the sunlit surface waters, and this process is called upwelling. Upwelling causes marine snow. Marine snow is made of organic matter and other particles that drift slowly down from the water's surface to the ocean floor where they decompose and contribute to the formation of sedimentary rock. As rocks weather, their sediments are eroded, which is the transportation of weathered rock. Erosion happens through a number of processes such as mass wasting, where gravity pulls weathered rock materials down a slope. Or it could be through a process called deflation, which is the removal of loose surface material like when wind blows dust away. The agents of erosion, including water, ice, and wind, shape the landscape by carving out valleys and canyons, transporting sediments long distances, and depositing them in new locations. Deposition is when the agents of erosion lose energy and the sediments they have been carrying are deposited in a new location. As a river slows down, it loses its power to erode and instead begins to deposit the sediments it has been carrying, which builds up over time and forms new landforms like deltas. Once sediments are deposited, they may remain relatively stable and turn into new rocks through a process called lithification, which is the transformation of sediments into solid rock. Over millions of years, pressure and chemical reactions turn sediments into sedimentary rock like sandstone and shale. All these processes, weathering, erosion, deposition, and lithification, work together to shape the Earth's surface. In places where rocks are uplifted, like in the Himalayas, weathering and erosion expose the oldest rocks at the surface, which means they're the first to be weathered and the cycle begins again. Weathering and erosion also depend on the climate. In areas with warm temperatures and lots of rainfall, like tropical climates, chemical weathering is intense. In areas with freezing and thawing cycles, like in the mid-latitudes, physical weathering dominates. And in dry climates with little vegetation, like deserts, both weathering and erosion are minimal. The rate of weathering and erosion influences the texture and composition of soils. In places where rocks are uplifted but not yet weathered, like in the Himalayas, there is little soil. In places with intense physical and chemical weathering, like the southeastern United States, soils are often rich in nutrients. In dry climates with minimal weathering, soils tend to be less developed and have fewer nutrients. The type of vegetation that can grow in an area depends on the type of soil and climate, which in turn influences the type of rocks that weather in that place. So, the rock and weather cycle interacts with the biosphere and the climate. And it's not just the rock and weather cycle that affects climate. Climate also affects the rock and weather cycle. For example, as glaciers move through a landscape, they carve out valleys and leave behind deposits of sediment called moraines. Moraines can alter the flow of rivers and create new lakes. Glaciers also polish rocks as they move, which affects the rate of weathering. And warmer temperatures can lead to more evaporation, which can cause droughts and wildfires, which can increase the rate of erosion. Climate and geology also affect natural disasters. Earthquakes happen when rocks along a fault line suddenly shift and release energy. The location of fault lines is related to the boundaries of tectonic plates. Most earthquakes occur along the edges of plates. Volcanoes, which we mentioned earlier, are also related to plate tectonics. Volcanoes often form at the boundaries of tectonic plates where magma from the mantle reaches the surface. Volcanoes can cause large-scale climate change when they erupt and put large amounts of gas and ash into the atmosphere. Tsunamis also have a geologic origin. They form when an earthquake or volcanic eruption or landslide causes a sudden displacement of water. The 2004 Indian Ocean tsunami, for example, was triggered by a 9.1 magnitude earthquake. Tsunamis can cause widespread flooding and erosion along coastlines. In addition to affecting the physical landscape, geologic processes affect the distribution of ecosystems and the species that live there. For example, the amount of weathering and erosion in an area affects the type of soil that forms and the vegetation that grows there, which in turn affects the animals that live in those ecosystems. Ecosystems also vary across the landscape based on the relief or the difference in elevation between the highest and lowest points in an area. Areas with high relief have a great deal of variation in elevation. A mountainous landscape with high relief has many different habitats within a small area, which increases biodiversity. On the other hand, areas with low relief have few variations in elevation and usually support less diverse ecosystems. All of these dynamic systems are also affected by humans. Humans mine the Earth's crust for resources, and our extraction of oil, coal, and natural gas has led to changes in the lithosphere, atmosphere, and hydrosphere. For example, mining creates new landforms and alters the chemistry of the water in the surrounding area. Oil spills and acid mine drainage affect the quality of the water and harm the plants and animals that live there. Mining and the burning of fossil fuels have also led to climate change, which affects weathering, erosion, the rock cycle, and even the frequency of natural disasters like floods and droughts. Human-induced climate change is altering precipitation patterns, which are already having an impact on erosion and weathering patterns. For example, in some places, increased temperatures and a decrease in snowpack in the Arctic are leading to increased erosion and the thawing of permafrost, which releases methane and carbon dioxide into the atmosphere. The location of geologic features also affects where we settle and where we get our natural resources. Minerals that are used to make everyday items like computers and cell phones tend to be located in specific places. For example, most of the world's tin and tungsten come from just a few countries. And since these resources aren't evenly distributed, they create economic and political relationships between countries. Countries that have mineral resources tend to use them to create wealth. For example, mining brought wealth to Chile in the early 1800s, and today it is one of the top copper producers in the world. But the environmental consequences of resource extraction can affect other countries. For example, when the United States bought most of its tin from Mexico in the 1970s, it had an incentive to help Mexico improve its mining technology to produce higher quality tin. In turn, this created health problems for nearby communities who didn't have the technology to process the ore safely. Humans also rely on the geologic record for energy resources like oil and natural gas and coal. The presence of oil, coal, and natural gas affects where people settle and how economies develop. Much of the Middle East, for example, sits on top of vast petroleum deposits, and these reserves have created wealthy states with significant political power. But the extraction and burning of fossil fuels has led to changes in the atmosphere and hydrosphere and has had significant effects on climate and weather patterns. As we move forward, understanding the interactions among the lithosphere, atmosphere, hydrosphere, and biosphere will be key to solving some of our biggest problems. The rock and weather cycle, plate tectonics, and natural resource distribution all play important roles in shaping our world and our lives. So next time you look around you, remember that everything you see is part of a dynamic system that is always changing. Many maps and borders represent modern geopolitical divisions that have often been decided without the consultation, permission, or recognition of the land's original inhabitants. Many geographical place names also don't reflect the indigenous or aboriginal peoples' languages. So, we at Crash Course want to acknowledge these people's traditional and ongoing relationship with that land and all the physical and human geographical elements of it. We encourage you to learn about the history of the place you call home through resources like Native Land CA and by engaging with your local indigenous and aboriginal nations through the websites and resources they provide. Thanks for watching this episode, which is filmed at a studio and was made in partnership with a digital studio and nature. You want to help keep this content free for everyone forever. You can join our community on a crowdfunding platform.